contain any dust load or any condensable liquid load within itself. So, this metal frame packed with core of knitted metal mesh is the cheapest one, but simultaneously it has got comparatively inferior efficiency with difficulty related to impurity carried away by the hot gas. So please note it. Huh? Type 1, just लिखे ना, type 1 is type 1 matrix है कि type 1 is cheapest in price, but though it is simple, it may not have good heat transfer characteristics. Full stop दिए इधर. Full stop. Most difficult part is the entrainment of entrainment, entrainment of dust loading into the matrix of any of the gases. Now the type 2. This is made of corrugated metal sheets called laminar flow wheel. How the corrugated metal sheets look like? এখন খুব বেশি আর পাওয়া যায় না, but if you look around, poor people still have some asbestos roof, and these asbestos roofs are made corrugated sheets just because the rainwater can flow through those channels smoothly. The question is, if we put two corrugated such plates one above another, a gap, keeping some gap between these two, automatically there will be a laminar flow, because you don't have any possibility of very high velocity flow through this, because highly resistance will be created. I mean, rather in the flow, the resistance will be pretty high, because if you don't make sufficiently good gap, I mean, if you want to make it a sufficiently good gap, then obviously the effect will be the just gas will flow through it, but no heat transfer will be possible. So you have to make it sufficiently narrow gap. If you make a sufficiently narrow gap, automatically the velocity will be low, and that's an advantage. You will get the corresponding heat transfer. But and that's why it's called alternately called laminar flow wheel, because in this type of wheel, the corresponding gas flow is always laminar, never turbulent. So this type of corrugated metal sheets are alternately called laminar flow wheels. It has got the advantage, disadvantage, like just write down. Type 2 is better with respect to dust loading, as it is a through passage, so dust loading is less here, because metal mesh is a zigzag path, so dust loading automatically will be higher, but it is a through passage. So type 2 is better with respect to dust loading, but heat transfer characteristics and pressure drop both may be inferior than the type 1. So obviously the type 2 matrix is desired only for specifically high dust loaded gases. Now the type 3, made of ceramic matrix of honeycomb configuration. Honeycomb মৌমাছির চাক. typical hexagonal structure. In fact, এখন তো সবকিছু বলা হচ্ছে যে ফিউচার সাস্টেনেবল ইঞ্জিনিয়ারিং এ all the things will come from the nature based solution. Means look around your nature, you will find out the better solution. Nature has made it. Honeycomb structure is a very special, typical, special, typical, not special, typical, very special structure in which it is very compact, overall volume will be less, but corresponding heat transfer area, surface will also be more. Even pressure drop will also not that significant. Because it's a hexagonal means within the given volume, you are getting more surface area. And in fact, the bees has made that structure in the natural process to store more honey into that within the given volume. I mean, overall given volume. So this honeycomb structure is usually used for comparatively higher temperature around 875 degrees Celsius. So comment on this is type 3, just like type 3 is a costlier option. You have to make that honeycomb structure, manufacturing, etc. Everything will make this costlier. Type 3 is a costlier option, but with a better heat transfer characteristics and hence is preferred for significant amount of waste heat recovery and hence is used for significant amount of waste heat recovery at a higher temperature. এটা কোত্থেকে বললাম? কারণ তোমার ইনভেস্টমেন্ট জাস্টিফাইড তখনই হবে যখন তুমি করসপন্ডিং গেইনটাও সিগনিফিক্যান্ট পাবে। মানে আগের দুটো কিন্তু কম্পারেটিভলি লো কস্ট এবং ওখানে if the availability of heat is relatively low, the investment cost may be justified. But in type 3, as this is a honeycomb structure, making and fabricating these things is a costlier option. And obviously, this will be used for significant amount of waste heat recovery. For any case, this is better than the other two, but cost is higher. Now is coming the type 4. The type 4 they mentioned is it's called hygroscopic wheel. This is mentioned that it is either of the second or third type. That means structure wise, it can be corrugated metal sheet or it can be of honeycomb structure, not the metal mesh. But then these are coated with a hygroscopic material which absorbs latent heat. What is the idea? You know that in any flue gas, there is significant amount of vapor, water vapor specifically. And as that water vapor passes through those structures, then it may pass as vapor. That means what happened? The latent heat is not extracted in the matrix structure. To extract that latent heat, either you have to condense or cool up to the acid, I mean that so-called acid condensation temperature, or you can absorb that vapor by some hygroscopic material so that the latent heat will also be absorbed. Obviously, the performance of this type 4 is the best because significant amount of heat transfer can be achieved by even utilizing the latent heat of water vapor in the flue gas. But from your common sense, you can get an idea. This needs a regular maintenance of recoating because this hygroscopic materials cannot last long with the cycles of heating and reheating, and rather the impurities also get absorbed into those. So just comment on this type 4 is, though the type 4 is best with respect to heat recovery, though the type 4 is best with respect to heat recovery, It needs regular maintenance, and hence cost effectivity of such wheels must be justified against its heat recovery. ঠিক আছে? তাহলে আই গেস মানে এইটা তোমাদের এমনি আঁকার দরকার নেই, just I'm showing you a pictorial view how actually it happens in a three-dimensional view. So here there are two side by side duct. One is the hot air that is passing, and obviously depending, and there is a motor which rotates this heat wheel at a low RPM. So obviously the hot gas that is passing through one duct is passing through the matrix to transfer its heat, and then subsequently in the another gas in a cyclic process, when it is exposed to the colder fluid duct, some heat will be carried away from that section in the other duct. So this is just to show you in the three-dimensional view, which was shown in section in the previous view. So the pictorial view of a heat wheel, this is just I've taken from that David Rees book as it looks from the one side of an industrially installed heat wheel. এর ছবিটিতে আঁকার কিছু দরকার নেই, জাস্ট তোমাদের দেখার জন্য করেছি। This is another next option is the run around coil. তো কটা বাজে গো? 8:40, ঠিক আছে, সময় আছে। Okay, what about the run around coil? If you look into the structure itself, you can understand this is used when there are two gas flows not at a very far off distance, which are at different temperatures. If these two gas flows are at a far off distance, then it may not be possible to make this work. Why? Because the idea is very simple. We have a circulating pump, selection of proper heat exchanging pipes, obviously insulated outside, but exposed inside those ducts. And then, as it passes through this duct, we must be assured there are two issues. Due to this circulating pump flow, there will always be a power consumption, electricity consumption. So, if the pressure drop inside the pipe is more, then that has to be paid against the electricity consumption. And you need to have sufficient heat exchange in both the ducts. Based on that, this is possible only if the available two gases at different temperatures are not at quite far off distance. Otherwise, the corresponding heat loss and the pressure drop both will be significant. And this has got a very common applications in the area of HVAC, heating, ventilation, and air conditioning. Because as I have mentioned, in several heating, ventilation, air conditioning applications, there will be some hot gas. Say currently, if we go for any air conditioning system, the air that is coming from outside must be hotter than the air that is going out after the cooling process to replace with the fresh air. In that case, if the hot air that is coming in into the system, if we can cool it in the process of heat exchange, at least the heating load on the air conditioning system will be less, because it will enter into the system at a lower temperature than the ambient temperature. So exchanging heat between these two different temperature fluids available at a smaller distance will be very much effective for the waste heat recovery purpose. But obviously the here most critical part is the working fluid which will be used for this purpose. It needs to flow with lesser pressure drop, and simultaneously there is not much of scope of heat exchange in this process without extending field heat transfer surface. So all this, I mean, the heat exchange surface on in both the tubes are generally filled, has to be filled. Otherwise, you don't get effective heat transfer at all. So obviously, these are fin tubes, and fin tubes are money into corresponding flow will also get. There will be a pressure drop associated with passing through the fin tubes. A design will look into each of these heat recovery, waste heat recovery designs, a very interesting engineering challenge. And in fact, companies are dedicated for each of these products. There are companies who are completely dedicated to manufacture and marketing heat pipes, several companies all over the world. Rotating regenerators or heat wheels, there are many companies in the world who are very famous for, according to a specification, they can supply. And this runaround coil is also another comparatively smaller budget companies. They are involved in this manufacturing process. Heat pipe business is pretty high. Rotating regenerator is a bigger component, especially in air purifier in power plants. It's a costly equipment. So obviously, I mean, big companies are involved in those marketing. But here, these are the smaller components which may be supplied by a company with a smaller financial capacity. So here I don't want to explain much, only you have understood that this circulating pump power consumption and corresponding heat transfer enhancement at the two sections is the most important part. And I've shown one header tank. Header tank, the idea is basically if there is any leakage and other things, or if you want to have some more waste heat available, then what is possibility? So obviously you have to increase the fluid flow rate of the working fluid through the circulating pump. Permanent, depending on the available waste heat flow or waste heat recovery or rejection, whatever you call it, you can utilize by enhancing the fluid flow rate, and that fluid flow rate can be adjusted by using this header. And lastly, the fluid must comply with the corresponding solidification temperature and boiling temperature, because in this flow, obviously you can understand, in any section due to cooling, if it solidifies, then the entire flow will get choked and simply it will just burst. And on the other hand, if it is converted into vapor within these pipes, then also vapor resists the liquid flow. So it need to be either way, cannot be condensed, it cannot be evaporated nor solidified in any of the sections. So your selection of the working fluid is the most important issue, and locations of the two sources of heat, that means from source to sink, that's the very important part in the runaround coil. But it is very simple waste heat recovery device. I mean, I call it, rather it's a cute one, not much of complications, only the selection of proper working fluid and availability of such sort of two different temperature fluids are generally available. One of the case sample is heating, ventilation, air conditioning applications. It can be other applications also. I guess no query up to this. Plate heat exchanger, I can just show you. I'm telling, I will not give any question in the semester also in the plate heat exchanger, because the designing of plate heat exchanger. But as I told you, alternately very thin plates will be located in such a way, so that not alternately, subsequently the thin plates will be arranged in such a way so that alternate channels are developed through which alternately hot, if you put multiple thin plates, then channels will be created, and in those channels, in alternate channel, hot and cold fluid will flow. তাহলে কি হলো? Any hot or cold fluid within the intermediate channels are always surrounding on the both side by other temperature fluid. And also the thin plates means conductivity is very low. So as I have discussed, that it has got the most important limitation that it cannot survive at any pressure difference, because so thin plates means it doesn't have any strength. But heat transfer characteristics is very good. But plate heat exchanger I don't include generally in the semester exam, or other in your just as a part of your syllabus, because its design is not that easy as I am describing. There, how to maintain these gaps and other things. This is maybe the next interesting topic. Here you have to follow a little bit the structure. We have this is called pebble gas heaters. So what do you mean by this? Think of marbles or those things. বাংলায় বললে ছোটবেলায় যে গুলি খেলেছি, আমি তোমরা গুলি খেলেছো কিনা জানি না কোনোদিন. Glass made marbles are available as children playing toys or other playing objects. And this pebbles are basically looking like those marbles, but they are not made of glass. They are made of high heat capacity material. I'll come to that part later on. Combinations of aluminum oxide and silicon oxide. So these have got very good heat capacity. Means for small temperature difference, they can absorb large amount of heat. Now, this pebble gas heaters can be either utilized for waste heat recovery, or it can be utilized for simple by burning process or fuel utilization also. If it is by fuel utilization, then obviously there are burners. If it is waste heat recovery, then there may be the hot gas flowing through this passage. So what do you expect to see? Your hot gas created by this process is entering into the hitting this collection of pebbles on the upper chamber. Now, as these pebbles are heated, then they are passed through a narrow passage to the bottom chamber, and in bottom chamber, comparatively cleaner gas, say air or so, is being passed from the bottom, cold air inlet, and there are some perforated passage through which air can pass and the pebbles can also come down. Now, as the air is entering into the system, it has to find out its path through these interstitial spaces. And then these are heated pebbles, means significant amount of heat will get transferred from these pebbles to the passing air through this gap of between the pebbles. Then hot air outlet, it is coming out. And what will happen to the pebbles after it comes down, comes out from the bottom chamber? You have to use some elevator. Material handling a bucket elevator porano hoyeche kina. So bucket elevators are basically, they look like a bucket. The pebbles will get dropped here, collected here, and then with the elevator, with certain speed or movement, it just transfers back to the upper chamber. And here there are another important issue. The gas flow, this has got certain resistance, pressure drop, whatever it may be. But more important is the stable solid pebble flow from the upper chamber to the lower chamber. And sometimes it happens during operation, this passage gets choked. So what to do? For that, there is a provision of pressure control connections. There are two channels are connected to the upper chamber and the lower chamber. Now think of the situation. If there is a choked situation, the solid is not flowing, then pressure on this section is increased and corresponding pressure in this side is also decreased. So across this pressure difference increased, the solid starts flowing again. But obviously, this is withdrawn immediately because in that case, you are forcefully sending the pebbles to the lower chamber, and that may cause inferior heat transfer characteristics. But if the flow passage gets choked, then automatically you need to carry out the process only through the creating larger pressure difference between these two chambers, upper chambers and the lower chamber. আচ্ছা, any query up to this? কারণ এইটার একটু বুঝতে হবে বা বুঝে নিতে হবে রাদার। আমি একটা ছোট টেক্সট বলবো, কিন্তু তোমাদের কিছু যদি আগে কোয়ারিজ থাকে সেটা আগে আনসার করে নিই।
ঠিক আছে স্যার।
ঠিক আছে, তাহলে একটু বলেই নিই, ছোট্ট করে জাস্ট টেক্সটটাকে দিয়ে দেওয়ার জন্য দিয়ে দিই। এখানে লেখো, ইন পেবল বেড হিট এক্সচেঞ্জের, ইন পেবল বেড বা পেবল গ্যাস হিটার্স যা বলা আছে, ইন পেবল গ্যাস হিটার্স heat transfer media heat transfer media between two gases are small pebbles carrying the heat from a upper chamber to the lower chamber. Full stop. In upper chamber, the pebbles are heated. In upper chamber, the pebbles are heated either by a burner, using fuel, or through waste heat recovery. Full stop. These heated pebbles, these heated pebbles are then transferred to the lower chamber through a connecting duct. Next sentence. Cold air passes through these heated pebbles. Cold air passes through this heated pebbles, sorry, and as the cold air passes through the small gaps between pebbles, in zigzag paths, because they cannot get a straight path, in zigzag paths, zigzag paths, cold air is also heated up. After the heat exchange, next sentence, after the heat exchange, from the pebbles in the lower chamber, These are transferred back to the upper chamber. These are transferred back to the upper chamber through pebble elevators. Full stop. The cycle continues this way. The cycle continues this way. Full stop. One operational problem, one operational problem is the choking, choking, choking of the pebble flow between the top and the bottom chambers. Pressure control, next sentence, pressure control connections are used to create enough pressure difference to remove this choking, to remove this choking, choking. ঠিক আছে, আমি আর এর থেকে খুব একটা আশা করব না, শুধু ডেসক্রিপটিভ টাইপেরই কিন্তু এইগুলো তোমাদের আমি রাখছি, কারণ পেবল গ্যাস হিটেস ডিজাইন ইজ ভেরি ইনভলভ থিং। সলিড ফ্লো ডিজাইন করতে হয়, তারপরে সারফেস টু সারফেস কন্ট্যাক্টগুলোর মধ্যে দিয়ে ফ্রিকশনাল এফেক্ট আসবে, ওয়ার আসবে, ওয়ার ইজ ভেরি ইম্পর্টেন্ট, কারণ এখানে কিন্তু সলিড আর রাবিং, সলিড পেবলস আর রাবিং এগেনস্ট ইচ আদার কন্টিনিউয়াসলি, তার মানে ডাস্ট এখান থেকে ক্রিয়েটেড হবে, সেখানে আবার সারফেস মেটেরিয়ালগুলোর ইস্যুসগুলো, ক্যারেক্টারিস্টিক্সগুলো আসবে। সো পেবল gas heaters design is very complicated involved thing. Only the basic physics you have understood. We have initially started heat pipe, where gas to gas heat exchange has been equivalently converted into two phase heat exchange process. Second is regeneration heat exchange process in the heat well. Third, we have run around coil, we have discussed there. Simply a liquid is flowing through these different temperature gases and transfer heat from one section to another through the finned heat tubes. Run around coil is not a very good efficient system for substantial heat transfer, but it is a very cheap option to get some gain. But pebble gas heaters are not that. This is just reverse. Installation of a pebble gas heaters must be justified with respect to the heat recovery. So available waste heat, just like regenerator, must be enough sufficient quantity so that the pebble gas heater's decision can be taken. So I'm not going to the design part, but as you have understood that each of these waste heat recovery has its own financial implications. All are not of same financial costing. And that's why at last of this particular waste heat recovery topic, I will discuss the so-called waste heat recovery economics. Unless the economics is justified through investment and corresponding recovery, corresponding waste heat recovery, better to say, otherwise the installation decision no company will take. So to take the decision of installation of a pebble gas heaters will be justified only if significant amount of waste heat can be recovered, which is actually generated by fossil fuel burning. I mean, you have costing from either side. If you don't make this waste heat recovery installed, then fossil fuel based heat will go away from the system, or rather will be wasted to the atmosphere. What does it mean? Some of your money invested in the fuel purchase will go away in the atmosphere. So if you want to recover it, then the installation cost and capital, we call it capex and opex, capital investment expenditure and the operating expenditure together must justify the corresponding saving in corresponding fuel price. That economics part will come later. But my idea of discussing this thing is, don't think that all these waste heat recovery equipments are used for similar applications. Rather, the type of waste heat recovery equipment will be selected purely on the basis of available waste heat quantity, quality, both. Next, the pebble gas heaters. As I have mentioned, that pebble air heaters are designed to heat air and other gases to higher temperatures, even up to 1000 degrees Celsius. So obviously, you can understand to what extent this pebble heat capacity has to be there. And then obviously it will be economically feasible using the recuperative principle. Means we can install this if it is justified that we can gain a temperature of the range of around 1000 degrees Celsius. And the spherical pebbles diameter is almost 0.5 inch. That time it is a British book and the mention was in inch. You can convert it into centimeter, millimeter also. Mullite composition, we call it, as it was. Aluminum oxide 72%, a 70-30 ratio. Aluminum oxide and silicon oxide together, they make it a mullite composition. And these two are together, the mullite composition is quite good for corresponding high heat capacity requirement. The applications are air gas heating hydrogen or natural gas for the reduction of metallic oxides. These are the chemical processes for which such heatings may be also required. Producing ethylene from a hydrocarbon feed source. In fact, I can tell you very honestly, I don't know the details of these two processes other than air gas heating. But pebble gas heaters are required for gas heating. There is no doubt about it. But that gas heating is purely gas heating for some heating purpose or some subsequent chemical reactions are associated with this. Those things I don't know, but I know that the pebble gas heaters are used for ethylene productions, and hydrogen or natural gas heating is also required to remove for reduction of the metallic oxides. These are better known by the chemical engineers. Any queries up to this?
No, sir.
Okay. আচ্ছা, রিকুপারেটিভ বার্নস আমি পড়াবো না, তোমরা বুঝতে পারবে না কারণ কম্বাসন তোমাদের জানা নেই, ছেড়ে দাও। আচ্ছা, এইখানে একটা ইস্যু আছে ইকোনমাইজার। কটা বাজবে বলো তো? আমার আইডি দিল্লি থেকে আবার ফোন আসবে 9টা 6। ঠিক আছে, 9টা 6 বারে 8:14, 15 আর 15 মিনিট আছে, হয়ে যাবে। 9:30 ওকে ক্লাস ছেড়ে দিতে হবে। আমি এবার এটা এই মোডে রেখে ক্লাসটা করছি।
ঠিক আছে।
ইকোনমাইজার্স দেখা যাচ্ছে তো? কোনো অসুবিধা নেই তো?
হ্যাঁ, দেখা যাচ্ছে।
তাহলে ইকোনমাইজার্স টেম্পারেচার গুলো ফারেনহাইটে আছে, লিখে নাও একটু, তোমরা পড়ে না সেলসিয়াসে কনভার্ট করে নিও। ইকোনমাইজার্স ইউ হ্যাভ অলরেডি স্টাডিড ইন বয়লার্স। ইকোনমাইজার কিন্তু শুধু যে বয়লারে থাকে তা নয়। Economizers, the name itself comes from that which economizes. Economizes means that which makes a better waste heat recovery and justifies the economics. Now, one of the area of that particular economizer application is the boiler, because in boiler, the flue gas after passing through the so-called superheater and evaporator, rest flue gas heat is also significant amount. So if you allow it to go to the atmosphere, then there will be a significant heat loss. So what you can do, an economizer section you can put at the last section of the flue gas before it is going to the atmosphere. আচ্ছা, রাজু, মনে হচ্ছে তোমারটা অন থাকলে অফ করো, তোমার এই সাউন্ডটা মিউট করো, কারণ আমার এখান থেকে তো শব্দ আসছেই, প্রচুর উৎসব হচ্ছে, তোমার এখান থেকে তো না আসে। হ্যাঁ, তাহলে ইকোনমাইজারের বেসিক স্ট্রাকচারটা কিন্তু ইট ইজ নাথিং আদার দ্যান a simple shell and tube heat exchanger structure. Tofat, what is the special characteristics of economizer? This economizer generally used for heating liquid exactly at the saturation temperature or closer to that, especially in boiler. Boiler installation ta ki holo amar? First, যদি আমি property water heating process টা যদি if I visualize, initially there is sensible liquid heating up to saturation temperature, then constant temperature evaporation process, and then we have got the superheating. তাহলে এই তিনটে ফেজের হিটিং এর মধ্যে corresponding equipments are also different. Superheating has to be done separately in a superheater in the highest temperature section of the boiler. Evaporation has to be done in a drum type structure if it is a subcritical boiler. Two drums, top drum, bottom drum. Sometimes they call it steam drum, mud drum. And then there are two rows, or rather several rows of tubes connected to. The lower temperature sides are called downstream, downcomer, and the higher temperature side is called risers. So that's the, I'm not going to describe the boiler now, it's not my class, I'm of power plant. But after that, whatever heat is available, before going to the stack or outside to the atmosphere, it must pass through a economizer section. In structure, as I have mentioned, it is nothing other than finned steel tubes. Steel tubes, any boiler must have a very high pressure of steam generation. Generally, সবসময় very high হয় না, generally একটা water tube boiler pressure কিন্তু বেশ বেশি থাকে। তাহলে to survive that pressure, the tubes must be also of sufficient strength, সেই জন্য এটাকে স্টিল টিউবসই করা হয়। এইবারে যেটা দাঁড়ালো, স্টিল টিউবস উইথ ফিন না করলে আমি হিট ট্রান্সফারটাকে ইমপ্রুভ করতে পারবো না। এছাড়া একটা এক্সট্রা ছোট্ট ইস্যুস আছে যেটা খুব ইম্পর্টেন্ট ইস্যু, মানে ফিন স্ট্রাকচার হ্যাজ বিন শোন হিয়ার, দ্যাট মিনস অ্যাজ ইট লুকস লাইক it has been shown an extended view so that the outsides are always must be finned. Now there is the important issue is as the flue gas is passing, here it is shown as 500 Fahrenheit to 300 Fahrenheit, you can convert it into corresponding temperature. What happens actually, the liquid is coming as the feed water from deaerator, that also we discussed in during our CCGT cycle also, and then it is coming next going into the drum. And obviously here in this process there is another important issue you must have to remember. From the energy economics or energy better performance, whatever may be the inlet water temperature, our desired temperature here is saturation temperature, because subsequently it will enter into the evaporation process. So if we can supply saturated liquid or saturated water, then that's the best option. But in fact, we never do that. Exactly saturation temperature, if you want to achieve, there is a difficulty. Difficulty means due to the operational fluctuation. If there is any pressure drop, that can happen always on the exit side. Automatically, that saturated liquid will get flashed into vapor. And if it is flashed into vapor within a liquid flow, then consecutively there will be a pressure fluctuation created, which is called water hammer. So, to avoid, and that water hammer causes the damage of the economizer tubes very fast. So to avoid that, usually a safe margin is kept always at the exit of the economizer. তাহলে যদি আমি টেক্সট পার্টটা এবার লিখতে চাই, আমার টাইম প্রায় হয়ে এসছে, আমার ফোন এসে যাবে আবার, তাহলে আমরা 9:30 অবধি আজ পড়াবো, তাহলে আমরা জাস্ট এটুকু লিখে নিই ইকোনমাইজারের বেসিক প্রিন্সিপালটা কি আর ওই ওয়াটার হ্যামার ইস্যুটা ইম্পর্টেন্ট, জাস্ট লিখে নাও। আর আরেকটা আছে ও অ্যাসিড কন্ডেনসেশন টেম্পারেচার, সেটাও তোমরা অলরেডি শিখে গেছো যে এক্সিটে টেম্পারেচার ক্যানট বি বিলো অ্যাসিড কন্ডেনসেশন, তাহলে ইকোনমাইজার ওই সেকশনসগুলো করেক্ট করে যাবে। তাহলে ইকোনমাইজারের ফার্স্ট ডেফিনেশনটা লিখে নিই। ইকোনমাইজার is a component. Economizer is a component বলবো, হ্যাঁ component waste heat recovery equipment করো, component ভালো লাগছে না। Economizer is a waste heat recovery equipment which heat water which heat water in sensible heating process. In sensible heating process. Full stop. Most desired temperature at the exit of the economizer. Most desired temperature at the exit of the economizer on the liquid side is corresponding saturation temperature. As this may be the as this may be the maximum possible heat transfer. However, if vapors are formed, if vapors are formed due to any pressure drop within the economizer, and subsequently again pressure raised, collapsing of vapor bubbles, collapsing of vapor bubbles may happen with significant vibration and loss of life of the economizer. This is called water hammer problem. This is called water hammer problem. On the gas side exit, on the gas side exit, if the temperature of the gas is below acid condensation temperature, and acid gases are there in the flue gas, it may cause acid condensation and severe corrosion of economizer tubes, and severe corrosion, CORROSION, of economizer tubes. Hence, the flue gas exit temperature of an economizer, the flue gas exit temperature of an economizer must be above acid condensation temperature within bracket about 10 to 20 degrees Celsius. if the flue gas contains acid gas. ঠিক আছে? আচ্ছা, you can understand from my mode of teaching in waste heat recovery, I am not going into much of technical issues of design part. Only I am putting up the basic physical features, and then I'm trying to make you understand the critical challenges. But obviously in actual design part there are many things involved. Say how much will be the, how many multi-pass economizers will be decided on the basis of heat transfer, what will be the fin size. These are all details are there, but purely under the purview of the mechanical engineers. Economizer design is a purely mechanical engineering job. But in this course I'm not going into those. These are basically applied heat transfer issues. That means whatever you have learned as a fundamental subject of heat transfer, that can be applied here to make the actual design. And obviously fluid mechanics is always involved in any heat transfer process. But my idea in this particular energy conservation course is not to give those engineering design, because each of the engineering design can take several classes. I mean, rather may not be possible to cover all in even in full semester. Economizer design can be so wide. So my idea is basically to identify the equipments in the waste heat recovery as some special few equipment, and then I will switch over to the waste heat recovery economics just within the semester time available. Okay. So next, whatever are there, I will not discuss it today because actually I'm really tired, or I may have a phone call. So waste heat boiler I will not teach. Next day this may not I teach. Let me see whether I can go for this. No, I will ignore also. The next day I will fluidized bed heat exchanger. I will little bit touch upon maybe on Saturday class, and then the waste heat recovery economics I will jump into. Any queries?
No, sir.
আচ্ছা, তাহলে এবার আমাদের রোল কলটা করে নিতে হবে। অ্যাটেন্ডেন্স শিট হ্যাঁ পেয়ে গেছি।